Hi everyone. So I guess I'm gonna do a small introduction for the VOD now. Um, so we're gonna implement type classes today in Polaris. So yeah, uh, I've already set up most of what we're gonna need. So we can define classes, and we can also hopefully, actually what about that? We can hopefully define instances. Like this. We cannot. Well, wait. Yeah, we can. Kind of. Okay, I'm gonna work on that. Hi, Christine. Um, and so, yeah, the interesting bit here is, Polaris' type checker is constraint based. So we are not gonna, so we're not gonna, we already, the way it works is, okay, there are basically two classes. There's the elaborator, the that walks through the syntax tree and generates constraints. And then there's the constraint server, which solves constraints, mostly equality constraints, but now there are also going to be type classes. Um, yeah, so it's in two classes. And we're going to start off with the elaborator mostly, because that's the easy part. And then we'll figure out how to do how to do the constraint server. Hopefully without needing to implement implication constraints, but we're gonna see about that. So, okay. Yeah. So the current state is if we just run this. Haven't touched this part of the code in a while. It crashes the instance. Let's comment that out. So the current state is this is the current error message. That's kind of a bit confusing, but the actual error is that okay, we are checking, this definition is checking f against this type. So it's scolemizing the type and turning like this a variable into a constant, and it would also need to like discharge the EQ here as a given constraint. So as a constraint that the instance can use in its definition. Oh, hi Goose. Missed you there. Yeah, so what we're looking for is in Scolemize. The way this, like this just pattern matches on the thingy, and dispatches for alls, but we're also gonna dispatch class constraints now. Yeah. So there's a class constraint in type. We're gonna do something. Hi, Yazal. Sorry if I'm mispronouncing your name. Yeah. So we're gonna do I guess it's kind of annoying. We're gonna need to match on the class constraint. How do you solve the actual constraints you set up? Yeah, that's in good question. There's a function called solve constraints. Yeah, that there's a these are the kinds of constraints that can exist right now. Unify is just an equality constraint, and those are kind of well, those three here are slightly like messy because like okay, so if you were to do something like a program call, like in Polaris you can do like this, and that's gonna run ls, and you can give the function an argument, which is just gonna be or you can give the program an argument, and this can be a string or a list of strings or a list of strings or anything like that. And without type classes, that had to be its own constraint right now. So that's what type right now. That's what those three are for, and this one's kind of complicated. But yeah, those are dispatched. Those are solved in by just iterating through the list, and unification constraints are just solved by unification. And we are gonna change this a bit. I've thought about this quite a bit because yeah, the class constraints are gonna work kind of like this. Like in this case, that's not the common syntax. In this case, when checking f, say we're like so f looked like this, and it's using EQ, which has an EQ constraint. Then inside this definition, there's going to be a given constraint of EQ a, and this is going to create a wanted constraint, also EQ a, and the way it's like GHC uses like implication constraints for local definitions, and that's kind of complicated. But the way we're going to do it is, for now at least, to just carry given constraints in the environment. So when generating constraints here, this remembers that there's a given constraint EQA, and then every wanted constraint will carry like a context. I guess we could write like this. That contains the given EQA, and in this case it's just going to be looking for EQA in the context which is already there. So this is going to be easy, but you might have like you might actually use an instance and have something like for all a EQ list of a or something. So that's going to be in the constraint solver. Like we're going to have an additional solve class constraint thing here. But we're gonna start with the elaborator because it's kind of weird to do this when we're not actually generating constraints yet. So yeah, let's start there. And yeah, I guess first things first, we're gonna need to carry constraints in the environment. That's not chapters constraints, right? Yeah. Oh, actually, already did. No, those are regular constraints, right? Those are wanted constraints, essentially. So I could rename that. Oh. So this is gonna be a list of given constraints, and just for simplicity, or actually, hi Chris. I guess it would make sense to use like actual constraints there, like any kind of constraint, also unification constraints, because well, it's not a thing right now, but if we had GADTs, we might have a given constraint that looks like a equals int or something. Actually, there are no ints number. But, you get the point. And yeah, we might. I guess we could already set it up so that those could be handled, although they can't be generated yet. Yeah, and those are just going to be yeah, given constraints are just going to be a list, because that means that more recent constraints are faster to look up for now. I guess like ultimately I'd want to use a more efficient data structure than just a list of constraints here, but we're gonna start off simple. Yeah. Yeah, but a list is nice because that means more recent constraints are well, earlier in the list, and so they're going to be solved more quickly. Like in this case, EQA is going to be the first constraint that's going to be checked. Yeah, this EQA. And so that's hopefully fine. Yeah, that's just an empty list. It's just an immutable empty list. That's fine. Is it? I hope it is. We'll see about that. Did I misspell given constraints here? Yes, I did. Great. Right. Yeah, okay. So if oh wait, how are we gonna do that? This okay, so we're gonna need to update the environment with given constraint, but kind of nice thing here is that Scolumize already does that, because like when checking against the definition, this A needs to be in scope in here. Like you could do like X colon A or something, right? And so this A needs to be in scope here, and so I guess we can just reuse that to get given constraints. Yeah, so I think it's just, actually it should be pretty straightforward. We just need to add this like transformer function, or like add the thing that adds given constraints to this transformer function. Yeah. Oh god, I gotta think about this. Do we need a new level? I don't think we do. No, that's fine. I hope. We're gonna find out. Yeah. So I guess we need to I guess we need to like collect all the like atomic. Oh, actually, we need to collect like the atomic constraints from the class constraints thing, because if you were to write like EQA and odd A, which you can't actually do right now, but if you were to, we'd need to treat these as like separate atomic constraints. I guess we can just do that. Yeah, that's fine. And that probably means the environment as well. Actually, that could just be could just return a list of type constraints. It's type constraint, yeah. Because yeah, that should be fine. And what's the syntax like? So the thing is, ideally Polaris really needs a kind system. I just haven't gotten around to actually implementing that yet. So there's right now constraints are just type classes are just type constructors. If I did that, yeah, right. Constraints are just type constructors of constraints would just be type constructors of kind constraint, like in Haskell. Like this EQ would be just a type that has kind, the type of a type, constraint, and A is kind type, for example. But that's not in place right now, so we're just gonna panic if it's not correct, I guess. Yeah, or I guess we can just ignore that. We don't really need to worry about that here. So only if it's a type constructor. And we're gonna do the interesting bit, and if it's anything else, we're gonna panic. For now, at least. Oh, actually, type aliases. We also need to handle type aliases. But that's easy because there's already a function for that. We can just recursively call this on, what's it called? Instantiate type alias, right? Yeah, like this just looks up the alias in the environment and instantiates it with whatever it's defined to be. So that should hopefully just work. What's wrong here? Oh, needs to be recursive. Yeah, I think that should work. I'm just gonna print out a slightly better error message. So we can just collect this as VOD. It's just like a class constraint. Does it need a location? Yeah, I think it does. So it needs a name for the type class and a list of arguments. And oh, actually, that's not gonna work, because yeah, that's not gonna work because we need like we need to have like instances like for all a EQA, a or EQ list of a maybe. Oops. Yeah, and that's not gonna work if you just carry this. So I guess let's just make a oh wait, there's already a class wait, what? There's already a class constraint type. Oh no, wait, what? Where am I using that? I don't think that's important. Actually, that's wrong though, because that can't handle it. Actually, yeah, no, that can't handle for alls, but it's kind of annoying because we can't like this can only be a given. This can't be a wanted, because you can't ask for like an instance for every a. So I guess let's just do a separate wanted constraint type. No, given constraint, not wanted. Those are wanted. So yeah, those are gonna need a class constraint thing as well, but we're gonna do that later. What did I mess up now? What's wrong? Okay, I messed up something. What? Oh, it's just the syntax error. Oh, that's it. Okay, it's actually fine. Yeah. So, given constraints. I guess let's just start with like a class constraint. Actually, no, that's fine. I think we can just have a list of variables and actually let's make that a bit more obvious. Like a list of variables and the actual class itself. And we're gonna have a list of arguments. And then, yeah, because it's a given constraint, we can just instantiate those variables. Although, I'm not sure we're actually gonna instantiate and then unify, because we don't want, like, when matching constraints, we don't want, like, unification variables to be bound unless we have to. Like, when matching against the class and like if it turns out we don't actually pick that instance, then we don't want any unification variables to have been bound by checking against that instance, if that makes sense. So yeah, we'll figure that out. And what did I do now? God. I'm slightly confused. Oh, it's mutual recursion here, and I missed the recursion. Okay, so that's fine. This is just an and that was scoped to the given constraints and not to the type constraint now. Yeah, there's no backtracking. That's on purpose, because like you don't want to do backtracking for type classes, because if you do, you're gonna like type classes are already not great for compile times, and you don't want like to check every single instance in the environment and have like exponential times. Yeah, exactly. Like it would be really nice to have backtracking sometimes, because you can't, like in Haskell at least, you can't have like a not constraint where you say does not like if this thing does not implement something, then you're gonna do something else, or like if it implements one or the other, you just can't do that, and that's because you would need backtracking for either of those. So yeah, like maybe if there's like a way to do like limited backtracking, that would be really nice. But in general, you don't really want to do that if you can avoid it. Yeah, okay. So we are we're gonna emit a given constraint list. Yeah. And that's actually yeah, okay. And this is fine because those can only be monomorphic givens. Right? We can't. The only way to get like for all A equal list of A is from a top level instance, or actually it doesn't have to be top level, but from an instance declaration, not from a constraint. Because this A is monomorphic, or well, it's not monomorphic in the scale of the function, but it's going to be monomorphic when when checking this thing, because A is just a golem. Yeah, so what did I call it? Class constraint, right? That's creative. So we're not going to have any variables because it's monomorphic, but we are going to have a class name and arguments. Yeah, that's golemization. That's actually surprisingly simple even. Yeah, so we have a list of givens, and I guess we just need to process the rest of the type in this case. That's the first thing. That's the golemized type, and alright, and yeah, this is like the second transformer has kind of an ugly edge case. I should have probably written like a note for that, to be honest. There's like a ugly edge case if you do like I actually don't know how GHC handles that, but if you do like this, yeah, this A needs to be skolemized by like when skolemizing this function, that also needs to apply to this A. So like type signatures need to, in declarations, need to like carry a skolemization function into the body, which is kind of annoying, but I guess we just need to do that sometimes. Yeah, but we don't have to worry about that, thankfully. So just continue recursively. And then we extend the transformer. I guess we can do that a bit more nicely. Is that just to? Oh yeah, that's. I'm never sure about the order of like function composition like this, but we need to do the inner thing first and then emit givens. I guess it doesn't matter. I think it doesn't matter which order we do this in. Hopefully. Yeah. So I guess this is just gonna be it's just gonna append. Oh no, it's gonna prepend to the list of givens. And that's fine. Prepending should be relatively fast. Oh, whoops. And those also need to be given constraints now, not type constraints, because those are just wanteds. Right. So I think scolumization should work now. What's wrong? Unbound variable in type checker. Oh no. That's here. Oh god. Okay. Oh, I know what went wrong. Oh, that's annoying. But we're not gonna worry about that for now. We're just gonna do the type checker first. Oh, I completely skipped the actual class definitions in here. Okay, never mind, we're gonna do that now. Like, we need to, in the renamer. No, wait, not in the renamer, in the... No, the renamer is fine. Oh, that's good. Yeah, it's, why did that... Oh, that's EVA. That's not types, right. In the type checker in, class definitions. Right, that's wrong. Yeah. This is wrong. Because we're inserting the type class, but we also need to insert every type class method as a variable into the environment. Like here, EQ needs to be a variable with type for all A, EQA, AA, tuple. Yeah, so... yeah, I guess we can just do that the same, similarly to what we did just now. Can never get the order of arguments in a fold correct the first time. Yeah, it's wrong. It's not, it's the other way around. So this just needs to be in certain methods, and yeah, no, that should compile at least. What's a method? It's a name and a type, that's fine. Right, yeah, of course it's a name and a type. What else would it be? Yeah, and names are already unique, because we have a renamer, so that's fine. But we need to add the class constraint. Actually, just... Oh, actually... What else? No, it's fine. That's perfectly fine, right? Yeah, right, you can't define a class EQ of int or something. Those are just parameters, so that's fine. And then we just add all the for alls on the front for all the parameters, because like EQ here is going to have type, I guess I should write that, for all A, EQA in AA, so tuple, right, like this. And so we're going to need to add the for all and the actual constraint. But that's pretty straightforward. list first, right? And someone's complaining, it's so annoying in OCaml that you, that like, constructors use like this weird tuple syntax. It's so annoying, like, because they're not even tuples. You can't even do like let x equals this thing. Like, that doesn't even work. So it's not even a real tuple, it just looks like one, and you just need to use the explicit tuple syntax and explicit lambdas everywhere. Not sure why OCaml works like that. But, yeah. Yeah, okay, so that's the type, and we just need to insert a variable of that type, so that should actually be it, I think. Yeah, perfect. Let's hope that actually works. Yeah, that seems fine. Yeah, that's eval. So oh, actually, the type checker already passed. Wow, that was quick. What if we use EQ? Yeah, then it gets a strange error message. Wow. Yeah, because it doesn't. Well, this thing scolomizes EQ correctly, but this doesn't instantiate it correctly. So I'm kind of. Oh yeah, the unification variables here just because this doesn't look like a function to it, so it tries to unify with a function with unification variables. That's fine. So we need to do instantiate with, which is pretty much the same thing as what we did with scolomization just now, just that we don't need to emit a given constraint but a wanted. And that's much easier actually. So yeah, okay, so it's gonna be a class constraint and the remaining type, and we're gonna collect wanteds. I need to define that somewhere a bit higher. Okay, what's wrong now? Syntax error. Oh yeah, right. Should probably finish one line before I start writing the next one. But okay, yeah, that's fine. So we can collect a list of wanteds, which is currently a list of given constraints, but that's probably wrong. So we want to emit it as a wanted, so I guess we should have a separate class constraint thing. It's just a class constraint, and we can have a wanted, I guess, let's name this. It's like a wanted class constraint, and we can also have a given class constraint. Right. And for now, we're not going to have any other given classes. I'm very much an FP noob. What's the elevator pitch for dependent types? Oh, for dependent types. Oh, not sure I'm the person to ask about that, but so dependent types. Okay, wait. Let me think of an answer. Um, so the idea is what dependent types do much more than even like OCamls or even Haskell's type system is that you can basically encode any property you want in your type system. So like if you want to write a function that, like, I don't know, takes a list, why not? Let's say you want to write a function that takes a list of something that where the list, like, I don't know, let's say the length of the list is a prime number and every second element of the list starts with the letter A. Let's say that, why not? You could write that down as a dependent type. You could have like a list of strings, and you can have a proof that like is prime the length of the list, and you can have what did I say? Everything like for all x's it starts with an a x, something like that. And now you have a function that you can only ever call on a list with prime length where every element starts with the letter A. And that's pretty powerful. Like, this is a contrived example, of course, but that's extremely powerful because you can just specify any properties you want, and you can write proofs about any properties you want. In your programming language, you don't need to like use a separate program to prove correctness. You can just do that in your programming language, and it's going to be checked by the compiler for you. And that's pretty cool. But yeah, I like dependent types, but I haven't. Well, I've tried to implement a dependently typed language yet, and I just haven't gotten De Bruijn indices correct so far. So maybe next time. Yeah, great. But yeah, Polaris is very much not dependently typed. Like, like there's a very concrete reason for that, which is that type inference for dependent types is hard to impossible. So yeah, and Polaris is fully inferred. Like, you could leave the type signature off, except does it? Well, maybe you can't yet, because yeah, generalization and things. But you generally almost never need type signatures in Polaris, like in OCaml. And so that's completely incompatible with dependent types. Yeah. Right. Yeah, and although most dependently typed languages do have type classes, for what it's worth. Yeah. But we're gonna need to change some things here. Oh wow, that's that's very elegant. We could just leave off the constructor, and it picked the correct type because of how I changed the record. That's kind of nice. Right, but no, those are wrong. Those need to be given constraints. What do they? Yeah, given constraints. Those constraints. Yeah, that's. What's wrong? Expression is type given constraints. No, it doesn't. Oh yeah, it does. Oh right. Whoops, I'm moving the wrong thing. That's why. I'm gonna need to map givens. Those are gonna be given constraints, and we're gonna prepend those to the existing given constraints. Partial match. Oh right. Now the constraint solver is complaining. But let's make sure instantiation works first. Yeah, right, so this creates a list of wanteds, and now I'm not actually sure how I'm gonna do that. Wait. Right, so yeah, I guess I'm just gonna add one of those things here. So like the list of wanted is just a mutable list because yeah, that's enough. Actually, shouldn't be a class constraint. It should be a actually, sorry. Actually that should be a wanted class. So okay, wait, should the class constraint carry location? I guess it shouldn't. This should. And the given constraint should also carry a location, so we can actually give error messages. Yeah. Yeah, can call it constraint because it's a keyword. Like, I've never used the constraint keyword in OCaml. That's like, I think the way it works is you can do like access like some variant or some object type constraint. Like, I don't actually know exactly how it works, but you can like constrain the way object types, like what fields objects can have somehow. But I've literally never used that. Only found out about that like a few weeks ago. Yeah. Right, oh, I'm also gonna add a trace. It's pretty important. And OCaml's, of course, OCaml's printing a thing is kind of annoying, as always. Because you can't just define show and then call that. Because unlike Polaris, OCaml doesn't have type classes yet. Oh, well. It's probably never gonna have type classes, but we can still hope. Wait, no, that's wrong. Actually, let's use a for symbol there, because it's cute and I can type it on my keyboard. Right, and that should hopefully print the thing. Yeah, I saw what there. Don't worry about it. And this is gonna be a wanted class constraint. Yeah, and that's it. Hopefully. What's wrong here? Oh, right. This needs a this needs a location. Oh, we have a location. That's good. Do we? We don't. Why don't we have a location here? I think we should have one. Oh, that's annoying. I'm gonna have to update everything now. But we should just be able to carry the location. Like, one thing that's kind of annoying that I'm gonna need to change at some point, but I haven't really gotten around to, is that like currently there's no I don't actually track any locations in types, because you like inside the type checker that you can't exactly carry a location around everywhere. But at least types that the programmer has written down should ideally carry their location, so we can like point to something more specific than the entire declaration here. But that's something to solve later. What's wrong? Alright. And now it's just a matter of updating everything to actually carry locations around. So, oh right, because there are two locations here. Wait, I'm gonna need to look at how that worked. Like, so let rec definitions, that's these kinds of, these definitions, like recursive, or function definitions that might be recursive. These have two locations, and I don't remember which one's which. I think it's just the name and the thing. I think that's in the parser. Yeah, right. Second one is just the variable, so I guess we should carry the entire location. What's wrong here? Oh, that's bad. Oh, that's really bad. Oh no. Oh no, no, it's not. No, it's not. Never mind. It's actually not bad at all. We just, yeah, this is the general purpose check function that checks an expression against a type. And if the type is polymorphic, it's scoldemized first. Like, that's what happens if you write like let x colon some polymorphic type. Then, actually no, does it? Yeah, no, that's what's gonna happen. But yeah, we'd need a location here, but we can just take the location from the expression that's being checked. I think that's fine. Actually, is it? Yeah, I think it is. Might be slightly off at some points, so might make sense to change that a bit later, like when we carry the actual type locations around. Then regular scoldemize also needs to carry a location. Right. Okay. So yeah, we have a list of wanteds, and we're gonna iterate over that and just create a wanted class constraint from it. So that's a class constraint right here. Those are class constraints, and we're gonna create a wanted at our current location. What is that wanted class? Is that? Oh, right. I'm gonna need to do this. Yeah, it's not. I can't return that yet. Oh, and instantiate also needs to carry locations for the same reason as Scolemize. So just a bunch of plumbing locations around. And this is also going to need to carry a location for exactly the same reason as before. So here, subsumption had a location before. Yeah, of course it had. Yeah. Like subsumption is when like generalized unification basically. So like in traditional Hindley-Milner you would just say two types need to be equal, and so you would create a unification between them, or a unification. Well, I mean, you still create a unification constraint, but you would just unify the two, but and like so that they're equal, and but with higher rank types you might need some notion of subtyping, where like a polymorphic type is a subtype of a more specialized type, and so that's what subsumption does. So just scolemizes one side and instantiates the other, and then unifies them. And that creates the subtyping relation. And this one already kept the location, interestingly. Okay. I mean, yeah. Kind of strange that instantiation didn't carry that one up until now. But now it does. Right. Okay, great. So we can emit the correct constraints. And I think that's all we need to do here. So we just can just continue the remaining type. Right. Right, yeah, and that seems to have worked. So, wait, actually, I forgot something. In a wanted constraint, we need to carry the constraint itself, but we also need to carry the list of given constraints. Yeah, that's kind of ugly the way it works here, but I guess it's fine. Yeah, because in GHC you would get a not in this case I think, but you would get a like local definitions would create an implication constraint that's like under the assumption that, like in this case, under the assumption that EQ of A, there's I don't know how to type the symbol that I use. It's just this like squiggly arrow. Under the assumption that EQA holds, there's a wanted EQA, right? And this is solved by basically just turning that into a given and then solving the rest. And that's like necessary for like GADTs, because well, I guess it's not. Is it necessary? I'm not sure. But like GADTs create implication constraints because you don't necessarily, like the left-hand side might not hold in every branch of the pattern match if you're matching on a GADT. And so that's an implication. But I think if we just do it like this, and just have every wanted carry all its givens, that should be fine. I think. Anyway. Right. So, yes. We're already at constraint solving. That actually went faster than I imagined. Right, so we have a location, we have a single wanted constraints and a list of given constraints. Yeah, that's a unify state thing. That's wait, what's that? Yeah, right. That's do we care about that? I think we. Oh yeah, we. Do we? I don't know. That's because you don't. It's like yeah, kind of weird to explain. That's when unifying, you might like the actual error might be deep inside the unification, but you want to keep the context, but you also only want to keep the context if it's necessary. Like if you're I don't know, matching like list a equals or list so list number equals list bool, then the actual error is only happens when unifying number equals bool, but you still want to carry that context around, right? And so this unify state is so that basically this is the error, but it also shows when trying to unify list number and list bool in the error message, but only when necessary. Like when matching number and bool directly, it won't show that message. And that's just, yeah, kind of annoying to write out, but necessary. Okay, so we are gonna match on the wanted. I guess if we just literally iterate through the list of givens, it's gonna be relatively straightforward, I think. So like one thing we absolutely cannot do is like unify unification variables from the wanted constraint here. Like if we had something like EQ, like wanted EQ question mark, like question mark A, some unification variable, or this, I don't know, it's called alpha, under like a given EQ of number, right? Then we could try to unify those two and instantiate alpha to number, and that would be technically be fine, kind of, but without like backtracking. Well, one issue is without backtracking, that's pretty bad because if like the rest of the constraint doesn't work out, like I don't know, maybe it's a bool in the string here, but we already unified alpha with number, then we would need to somehow undo that and like backtrack, and that's difficult. But also, we don't want to just guess types. Like there's in the outside in X paper for GHC, there's a whole section about like guess-free solutions. So like we never want to just unify a unification variable and take the first instance we find. We always want one that's like explicit. So like we're never gonna unify EQ question mark alpha with anything. Or not EQ, not unify, but solve. You know what I mean? Yeah. So there's the application and the class constraint. And what's the last one? The list of given constraints? Wait, no. Oh wait, that's the wrong one. That's should be wanted class. No, what? What? That's the wanted is a. Oh wait, wanted is just class constraint. I'm losing my mind here. So wanted, we're just gonna look for the class name first. Would be really nice if lists were lazy right now, but I guess they're not. so we're gonna look through every given constraint until we find one that matches our wanted. Okay, so how's that gonna work? Like ideally, I would want to like use or try to use unification and like lock the wanted in place somehow, but I don't think that's. I guess that's possible. No, it's not really. Like we could try to like replace every unification variable with a fresh scolum maybe, and then try to unify. But that's kind of is it slow? I guess it's not that slow. Let's try that. Sure, why not? So I guess we need to lock the wanted. And here we can use something kind of nice, which is Polaris' traversal system. And this is gonna return nothing, I think. Yeah, right. It's not gonna return oh no, wait, that's wrong. So I guess this is gonna take a unique map with that. No. Okay. It's kind of annoying. We need to get like a map. Okay, so we need to replace every unification variable with a fresh scolum, and we need to replace the same unification variables with the same scolums. That's the important bit. I think that's fine though. So we just need to carry it like a substitution around. That's like a type of set. Well, that's wrong. So we can still reuse the same logic here though. Like type refs are like references with a unique sort of an identity, similar to, well, it's exactly what we're using in the thingy, in unification variables. Hey, hi Uber, hi Claire. Yeah, okay, so wait, no, code of God, right? We're gonna need a type ref, or we're gonna factor this out, and then we can use the same implementation for a map. That's nice. Hopefully, yeah, right. And then we can lock our wanteds in place and replace every unification variable with a scolum. Yeah, we need to traverse types, nothing else. Haven't actually used this traversal logic in a while. No, I can't do that. I need to match on the normalized one. So I can't. The important bit is that like it only tries to substitute unification variables that haven't already been been bound anywhere. So that's this part. What's wrong here? Oh, whoops. That's with, not in. Right. Right, so the traversal will do this in every type and check if it's a unification variable, and if it is, possibly replace it by the replacement thingy we're setting up here. Takes an environment. Oh yeah, wait, does it? Why does that need an environment? Oh right, because it needs to carry levels. Yeah, that makes sense. But that's fine. Is it? Oh god, is it fine? I hope it is. Oh god, levels. Yeah, maybe we shouldn't use golems here. Well, we'll see. Might need to carry the level at which the constraint originated here. To get the level correct here, but let's put it to do down. Wait, no, that's actually only gonna do this if it's not in the map already. Right, so if we already replaced this unification variable, we're just gonna continue on, or we're just gonna replace it with this golem. And if we didn't, we're gonna create a new replacement. Right, that's pretty straightforward. Does that return a type? Yes, it does. Okay, that's great. So it's just replacement and add replacement. Maybe not. Typeref or.t. Typeref t. The name. It's carrying a name, really? Okay. Sure. And that should be exhaustive. Oh. OCaml syntax. Yeah. Because the that's a thing in OCaml where if you put a match inside another match, it it doesn't know which match the cases belong to, and when the inner match ends. Because in Haskell you'd use layout for that, and OCaml you just don't. You put like begin, end, or parentheses around it. Yeah, and that's our traverser. Oh, actually, yeah, that's yeah, we're just gonna need to apply that to the wanted arguments. Yeah, we're gonna throw the substitution away, I guess, because we don't need it after this one. And something's wrong. It's no method traverse tab. Oh, because it's traverse tab. Yeah, it was. Okay, great. And it's gonna need an empty map, of course. That's it. Perfect, so we are locking our wanted constraint in place. And now we are just... I guess we just need to unify it. Actually, I haven't thought about how we're gonna catch the unification error. Because I wanna change something about that. I guess that's fine. Okay, so say we're given a class constraint. And we're trying to match our locked wanted constraint, then I guess first of all we need to check if they're even about the same type class. Oh, actually, no, that should be named equal. So if they're not equal, I guess we can just return none because they're never gonna match. So if you like the wanted is EQ and the given is odd, this we can already abort here. And otherwise, we're gonna need to instantiate the given. So it's not. Is it? I guess it is instantiation kind of. Not regular instantiation. Yeah. So God, we're gonna need another traversal. And we're basically gonna do the exact same thing as here, just in reverse. Actually, that's pretty straightforward. So we are locking the wanted in place, and the given is going to be instantiated to unification variables. So instead of matching a unification variable here, this is going to match on type variable. And the replacement is not going to be a golem, but a fresh unification variable with the same name. That's, wait, what? Ah, right, that's name. And that doesn't apply here, thankfully. So, right, okay, so we're locking the wanted in place and instantiating the given, and then we just need to unify them, I guess. Yeah, that's, and like check any errors. The one thing I haven't entirely thought through is Polaris is row polymorphism. So you might have something like, oh god, actually that might work pretty well with what we've just done, because you might have something like like x current number, and you might have like a given, oh that's a, you have like a wanted, and you might have a given that's like for all r x current number in R has like also implements to Q. Something like, oops, something like this. And I think that should just work fine this way, because like unification for rows is kind of tricky. Like if we were to like re-implement unification just for type desk matching, that would be kind of difficult. But I think if we just defer to regular unification, it should just work out of the box, hopefully. And something's wrong. Oh right, because this also returns the substitution. But we don't actually care about the substitution. So that's our instantiated given, and then, oh wait, that's wrong. We just care about the, actually we just care about the instantiated arguments, we don't even care about the given anymore. And because we just solve unification constraints between those, or we try to. Might make, does it make more sense to solve the constraints, or try to solve the constraints immediately, or to just re-emit them and have them solved later? I guess we could just try to solve them immediately. Oh no, we need to solve them immediately. That's yeah, no. Because we don't even know if the instance matches at all. So we can do lots of unified work. Oh, that takes the local environment. Okay, so I guess we can change that now. We need to carry the environment at which the or the, what's it? What would that be? I guess the local environment, yeah, where the wanted was emitted. Because we need that for unification as well. Because actually we might not, because we just needed that for levels usually, but it might be fine, because I don't think we have any levels remaining after like locking and instantiating things. But we'll see. So I guess, yeah, this just needs to carry an environment as well. Okay, so we can just try to solve unification constraints between the instantiated arguments and the locked ones, and if that succeeds, then yeah, we just solve the constraint, and I guess we're gonna need to carry some evidence around later. Oh god, that's gonna be kind of annoying. But actually, no, that's not too bad, I think. But for now, yeah, we're just gonna mark the constraint as solved. Just solve unify need. It needs the environment and the unify state and the types and the local environment. And oh wait, do I need unification or do I need subsumption? No, oh, I'm basically doing subsumption, so I don't need unification. Okay, so the order of arguments is irrelevant. Yeah, and we're never gonna produce an error message anyway. That's fine. Guess we can just return unit here for now. And that's kind of annoying. We're gonna need to catch unification errors. There's not really anything in place for that right now. I guess it's just we can just catch any type error and hope that doesn't catch any invalid ones. Actually, we don't need to look the entire one, we just need to look the arguments again. But actually, when you match the result, and so if this succeeds, then I think we're just done. Yeah, if this succeeds, we're done. And if it doesn't, then that's the interesting part. Because for now we're gonna throw an error, I guess, but ideally this should be put back into the constraint server. How did I do that with other constraints? How I added that to the default constraints. Yeah, that's fine. Then let's just do that again. I'm gonna redo some of that later, but it's fine for now. So this is gonna throw an error. And in that case, we're just gonna add the constraint back. What's wrong? Oh, that's unify state. Oh, that's weird. So wanted class, and that's wanted constraints given is local env. Alright, because I don't actually care about those. Yeah, so that's correct, hopefully. And that's... Oh no, wait, that's perfect, actually, so it works, I think. think it works, because it just reports that the return type is wrong now. And yeah, that's perfect. It just fails an eval now, because I haven't written that part yet. That's perfect, and if we leave out the constraint, then it's gonna fail because I haven't written the error message. Right. Perfect. And I guess just, yeah, missing instance of some class constraint, which is just gonna be our, given, no, our wanted constraint in this case. So it's just gonna raise a type error. Missing instance. Wanted? Type definition dot class. What? This expression has type class constraint, but wants type definition dot class constraint. Oh, that's because something trees.grow. Is that correct now? No. Wait, but no, class constraints aren't. What? Oh, that's because there is. What is there? There's no type class constraint in. Oh, there is. Wait, that's wrong. I need to get rid of that one. And now it's just not in scope. Okay. So I just need to define the class constraint earlier. And I need to update the interface. And that's perfect. Now for an error message. What's wrong? This pattern matches values of type ABC, but pattern matches values of type class constraint. Wait, can't I match on a... Oh, it's semicolons, not commas. Oops. Oh god, what did I do now? Perfect. It's semicolons and okay, not commas. That gets me every time. Okay, perfect. So that's gonna be a type. That's not gonna be pretty tight because I'm going to do some disambiguation. Yeah, I think that's fine. I think that's it, actually. Yeah, missing instance EQA. Perfect. Wow, okay. So, as it seems like basic constraint serving should already be in place now. Yeah, perfect. Wow, that went quicker than I thought. Perfect, yeah. So now what's left is mostly carrying evidence around and like generating actual things to run at runtime. And also, alright, instances. I think those are broken for now. Yeah, those are completely broken. Perfect, but I guess I'm going to commit for now. Okay. Yeah, so next up, instances. And now we're gonna see how, I guess I should just write a test case for that already. How like generic instances with parameters work. Oh, actually, you can't even write that for now. Because if you just write list A, then A is gonna be out of scope, right? Yeah, driver not found. Perfect, so you can't even write those kinds of instances for now. How would you write those? You can. That's ugly. That's also ugly. Maybe. I guess let's go with instance A for now. Yeah, that should be how it works. Oh, wait, actually no, that needs to be instance A EQA in something. Yeah, I know it's kind of ugly. I don't know, like, for all A dot EQ list A. And that, oh, actually, that's, yeah, actually, you know what? I like that. Let's go with that one. For all A dot EQ list A, except that's not actually the one, but needs to be EQA in EQ list A. Yeah, that's fine. I like that. Let's go with that one. Yeah, and that should. Oh wait, that. Actually, yeah. Let's keep that as a separate test case. What's that called when you do the take the thing from the context? Like, there's a name for that. I don't remember what it's called. It's just called instance context, it's fine. Actually, instance context missing. Because this should generate an error message. Yeah, not sure that one's gonna be, but like this one should generate an error message like no instance of EQ int, right? Oh wait, I completely forgot about those. God, what are those called? There's a name for those. But those like, they're not super classes, but like super instances, I guess. I guess we're gonna need to deal with those. But yeah, let's try this first, because right now, I'm gonna need to change that later, but right now, yeah, right now double equals will just work on types, I think, on lists, I think. What? Yeah, right, that just works. Gonna, let's not mention that. Yeah, okay, so, but first one's gonna be top level instances, because those should already be solvable at least. So we're only gonna do instance EQ number, and then we're gonna do Q5, and that's gonna be true. Right. And that's gonna crash. Okay, alright, there's an annoying thing here. Yeah, because like there's a bit of baggage around that, and yeah, like let rect definition like how much is that? Like 50 lines. I'd rather just reuse some of that. Is that what I'm doing even? God, I haven't touched this part of the code in like months. Yeah, let's factor that one out. Okay, so we can just factor out almost everything here. Like the whole traversal thing. Wait, no, actually we don't, because we don't have a type, right? Or do we? I guess we don't care. We can just treat it. Can we? No, wait. Like we're not. Oh, that's interesting. No, we're not gonna name the type, right? So, yeah, actually we can't use that, because if we were to reuse the code from letterx, then like this would need to be valid, because that's the A coming from here, I think. Is it? No, wait, that one would have been substituted to be numberable. I think that's fine, but then we don't actually need that much from here. No. We're not gonna do that. Because we don't actually need most of what let rect definitions do, because most of that is checking against the types, checking either inference or checking against a type signature that might contain for alls, and we have neither of those in like in an instance. So we don't actually need to do that. So we don't actually need to scolemize anything here, that's just wrong. Yeah, we can just check the expression against the thing, and that should be fine. What's this supposed to return? Oh, right, just type name parameters body. Okay. Alright, so it's actually, yeah, already worked, I guess. Yeah, I guess this should return the instantiated type, that's fine. Yeah. It's looking good, so we checked all the methods. And I think that's it. I think that should just work. Oh no, wait, no. It doesn't, because we need to create the given constraint. How did I emit the given earlier? Or just manually, I guess. Then let's factor that one out. Yeah, that's fine. Let's put that here. Yep, whoops. Press the wrong button. Okay, and that was its location. Okay, why is this airing out now? Ah. Right, because I didn't actually finish that part. Okay, so we are going to emit a given constraint at our location for what's name? Yeah, for now, no variables. That's going to change in a second. And these are semicolons, not commas. And arguments. Right, but I think that's all we need to do to the environment. Then we can return that with our at instance thing. What's wrong here? Oh, that should be a list, right? We're gonna emit one. Yeah, and that's looking good. Type variable not found. That's good, but not exactly unexpected. And that's fine. Yeah, that means it. Well, okay. I guess I'm not actually checking for anything right now. But if we were to print EQ 5 and 6, and that's gonna missing instance EQ number. Never mind. Nothing of that worked. why didn't that work? That's strange. So we can like trace add some shape. That didn't work. What? I need to put it before the thing. Trace image. Right. So there's a wanted for EQ A15. The number is unified with A15, so now we have a wanted. Oh, I think constraint solving is not. Wait, constraint solving should take care of unification variables. I think that's fine. What's going on here? So this one doesn't match anything. Guess we can add some more extreme traces there. So this is gonna do that's yeah, so it's gonna check this thing. Yeah, we need to put it in here. So we need to pretty print the constraints again. God, that's getting old. Oh, I actually have an idea what might be going wrong here, and that would be pretty bad. But let's hope it's not that. That's what's it called? Trace. Oh, this we call trace class. Oh, that's oh no, wait, what? No, I'm tracing classes, but I'm not getting any traces. Huh? That's interesting. That's strange. What's happening here? That's very strange. This thing isn't. There are no givens. So I guess it's not inserting the constraint correctly. Maybe that's it. And that's probably it. Anyway. But why? It's doing emit givens. That should add some given constraints. Not sure what's wrong here. This should emit a given constraint. I guess I'll just print those. Wait, no, it's never oh no, I'm not printing any emitted given constraints, because I should change that. Oh, oops, missing the variables here. So wanted constraint should never have variables anyway, so it's kind of weird. Okay, so it's being emitted correctly. It's just not resolving the wanted. Some other. I've not used the VS Code account plugin. I think it has a debugger. I haven't used it before, but I don't really like those kinds of debuggers for type checkers, because I think it's usually better to just have like traces like this. I think, because you can. Like in this case, it's fine because it's relatively small, but if you have a larger example, it's kind of weird. Like unless you have like a extremely good time traveling debugger, it's kind of strange to step through everything. And so, just looking through a list of traces is usually easier. As long as those traces make sense, anyway. I guess in this case, a debugger would be nice. Does it work? Oh, something's happening. That's the wrong debugger. um, well. Really shouldn't try to run the .NET debugger on a camera. I'm not even... Okay, let's just leave that. Do I even have .NET installed? I do. Interesting. Yeah. But I'm just confused why it's missing an instance and why it's never actually going through any givens. What's going on there? It's like this should just add it to the environment. Does that thing work again? Yeah, because check seek expression takes an environment, and that's something about top level bindings and repls and things, and returns an environment transformer and the transformed expression, like the typed expression. So that's trees that grow. So it takes a renamed expression in, and it returns a typed expression that might contain more context, like variables contain types and typed expression. And that's what the language server uses, so you can like hover over things and see types. Well, you can't because it's crashing, but usually you could. I'm really not sure what's happening here. Guess I just need more traces. So this is emitting the constraint correctly. And then it's never actually solved, apparently. It is, the wanted is solved, but it's not. Actually, oh, I know where I can add a trace. I can. Oh, I guess let's do like an ad hoc thing. Wherever the wanted is emitted here, we can print the given constraints, or at least print the length of the given constraints. Yeah, interesting. So it doesn't have a given constraint where it's being emitted. Maybe the environment is wrong somewhere. So this is calling that with the environment, which is and the environment is, wait, what? So the environment here is the one that's being called when this is instantiated, right? Oh, maybe, no, it's not that the order is incorrect somewhere. This adds a wanted class. Class constraint, yeah. Not sure where I expanded that there, but yeah, so this adds a wanted class constraint for every thing, and it takes the environment from instantiated function. And yeah, and that one should contain the corresponding given constraint. Why does I know what's going on. Yeah, okay. There's a local environment and a global environment, and the global environment is what's propagated between top level definitions. And of course, given constraints need to be carried on in the global environment as well. Actually thought that wouldn't compile. Apparently it does. Unbound record field. That's wrong, right? Yeah. Okay, to global env. God, that's cause the class field has the same name. I'm sure that's not an issue with the other ones, but I'm gonna need to export givens. Let's do that later. Yeah, right. Modules are gonna need to export their given constraints as well. No, they're givens, not wanteds. Oh, that's what was wrong. Didn't actually need to call it global. I just called it wanted, not given. Whoops. Okay. And that doesn't match the definition because the global environment is exported. And I need to expose given constraints. But don't think I need to export the implementation, hopefully. And that's didn't make any difference. Wow. Wow. Perfect. Oh, yeah, I know why. Because I also need to build the local environment, to include those when building the local environment from the global environment. Yeah, type top level, that's the one. Where's that one? Oh, hey, I actually made the mistake earlier. So it did not compile, I just mixed up the definition here. Huh, okay. So it needs to be global after given constraints. And now? Yeah, now it's gonna work. Perfect. Yep, and it first tries to match... interesting. So it tries to match EQ of a unification variable, which fails because it can't match the unification variable, and then next time it tries, the unification variable has already been substituted. Perfect. Yeah. Great. Yeah, so it's working. Alright, I think I'm gonna end the stream here. Was fun.